Looking at number 8, how many molecules per liter of oxygen are present at 892 millimeters of mercury and 25 degrees Celsius? So when we are done, we will have molecules per liter. Now, I only know how to get molecules if I know moles. So that makes me think this idea of molecules here, I'm going to have to figure out how many moles I have per liter, and then moles I can convert to molecules because there are 6.02 times 10 to the 23rd particles, which in this case we're talking about oxygen, so it's molecules per 1 mole. All right, so gives us pressure, gives us temperature, talks about per liter. So I am thinking that we're looking at ideal gas law. PV equals nRT. And we know that pressure is 892 millimeters of mercury. Volume, moles, R 0.0821, and T, it gives us 25 degrees Celsius. So we add 273 to that, it's 298 Kelvin. Millimeters of mercury, you got to convert that to atmospheres because the unit on R is atmosphere liters per mole Kelvin. Volume will come out as liters, and pressure has to be in atmospheres. So multiply that. It's 1 atmosphere for every 760 millimeters of mercury. And so 892 divided by 760 is 1.174 atmospheres. All right, now here's where you have a choice. You could literally put any volume and any number of moles in here and figure out that relationship. Now me, I like to keep things simple. So since it's per liter, you could go 1 liter there, or you could go 1 mole, because I know that 1 mole is 6.02 times 10 to the 23rd particles. It's maybe contrary to what I just said about keeping it simple. I'm going to work it out both ways and then see if we get the same answer, because it actually doesn't matter. So if I use the 1 liter there, then when I rearrange PV equals nRT, moles equals PV over RT. So we're going to look at, it's going to be 1.174 times 1 over 0.0821 times 298 Kelvin. And so that means moles is going to be 1.174. All right, comes out to be 0.047985 moles. And then if I convert that to particles, it's going to come out. Why is this thing so close to the wall? Oh, what did I do? All right. Times the 6.02 times 10 to the 23rd. That number of moles is equal to 2.89 times 10 to the 22nd molecules, and that's per 1 liter. So that would be our answer. 2.89 times 10 to the 22nd molecules per liter. Now, what if I went back and worked it out a different way? I go back and work it out with 1 mole per X amount of liters. So all the other numbers stay the same. It's some unknown amount of liters, but we're going to plug it in as 1 mole. Well, then we're going to rearrange the formula. So volume would equal nRT over P. So it's going to equal 1 times 0.0821 times 298 over our 1.174. And that means that 1 mole would occupy 20.84 liters, which means that you would have 6.02 times 10 to the 23rd molecules per 20.84 liters. And when you divide that up, you get 2.888, so 2.89 times 10 to the 22nd molecules per liter. So it does not matter, you get the same value no matter which way you do it. If you work it out as 1 mole, if you work it out as 1 liter, you work it out as random number of liters, random number of mole, it would always circle back because you're looking at that relationship between moles and liters. And so as long as you don't mess up a conversion, you'll get the same answer, 2.89 times 10 to the 22nd.